So we're evaluating this limit as x approaches infinity, and that means that this is going to become a very large negative number. So that's going to go up to negative infinity. That's going to go up to positive infinity. So we have negative infinity times positive infinity, which is an indeterminate form. So we're going to have to use some other way to evaluate this limit. We can use L'Hopital's rule, but that works when we have quotients. So we have one function divided by another. So luckily, I can rewrite e to the negative x power. Since this is a negative exponent, I can rewrite this using my properties of negative exponents as e1 over e to the x. Okay, so now I can rewrite this as the limit as x approaches infinity of 5x squared times 1 over e to the x. I could simplify that a little and say the limit as x approaches infinity of 5x squared over e to the x. Okay. Now I have a function divided by another function, so I can use L'Hopital's rule. So now I can just simply take the derivative of the top and the bottom. So I want the limit as x approaches infinity of 10x divided by the derivative of e to the x, which is just e to the x. Okay. Now, if I evaluate this limit at really large numbers, again, this is going to become a very, very large number. Okay. And this is going to become a very, very large number. So I'm dealing with some sort of infinity over infinity. So still an indeterminate form. So I'm going to take the derivative one more time. So I have the limit as x approaches infinity of 10 over e to the x. Now, as x gets very, very large, this number is going to become very, very large. So my denominator becomes very large, which means overall my number is going to be really, really small, and eventually it's going to approach 0. So the limit as x approaches infinity of the expression 5x squared times e to the negative x is also equal to 0.